Well, hi, and welcome to my talk on how FOSS4g, or free and open source software for geospatial, fits in your stack. Now, my name is Art Lembo, and I'm a professor at Salisbury University. And this presentation was actually put together by a number of my students, Kevin Bedwell, Steph Deanna, Logan Hall, Kyle Kim, Adam Phipps Dickerson, um, Ethan Ray, Katie Stafford, Kyle Tadurin, and Chris Windsor. They were all part of a class where we decided to look at all the different technology stacks for free and open source GIS. And we did this in the spring of 2020, right in the middle of the coronavirus pandemic. So all of this was done online, all their learning was done online, and all their collaboration was done online. So hopefully this will give you a good overview of the different technology stacks that open source GIS can fit into. Now, FOSS4g, as I said, stands for free and open source software for geospatial. So there's a lot of open source software out there, and a community has come together to create software in the GIS or geospatial field. So this is open software. It's free to use, all the ones that we're talking about. You can also modify the source code to improve the source code, but again, that's usually handled by the main gatekeepers, the people who are maintaining these products. And we're going to look at these products in the form of three different technology stacks. So there's desktop GIS, you're probably familiar with that, but server-based GIS as well as tools for the developer. And when we say desktop GIS, we mean QGIS. So that is a desktop GIS that performs map creation, spatial analysis. When we say server-based, we're looking really at database storage and manipulation. So that's Postgres, and there's a GIS component that goes along with this. And then when we talk about developer, it's also partly server as well. So Geoserver is actually a web-based server to do internet mapping. But we can also do more programming on the back end of things like Postgres and write our own Python code as well. So these are the kinds of technologies you'd probably come across in a traditional GIS ecosystem where you have things at the desktop level, the server level, and things that you are dealing with the developer level. Now, this was my students' first exposure to FOSS4g. Now, we've ordinarily been using commercial-based GIS software, so we thought this would be a great opportunity to learn how to use some free and open source software. And it was a one semester class, so it wasn't like we could become real experts in this thing, but we could get a pretty good feel for how the technology works. So we looked at the software from the three different technology stacks. We also spent a little time looking at SQL. Now, we could have also looked at Python, but that was probably a little bit too much to bite off considering we're going to work with enterprise GIS management with Postgres, as well as QGIS and Geoserver. So to do Python programming would be a bit much. So some of my students are doing independent studies with me on that. After 2 months, they built a web page for the town of Denton, Maryland. They created interactivity with the user along the web page and also had built-in SQL queries that connected to an online geospatial server. In fact, it kind of looked like this when we were all said and done. We had our server here, and what was in the server was Postgres, which is an enterprise class relational database management system. It had something called PostGIS that's bolted onto it, and that provides the spatial constructs and the spatial functionality within an enterprise GIS. We also had Geoserver running on the server, which is a server-based GIS that produces internet mapping capabilities. We had desktop software, so we learned QGIS, but we also demonstrated how software like Manifold, ArcMap, and others can interact with the GIS data so that we can have multiple users performing different types of editing simultaneously. We also did a little bit of Python scripting, mostly cookie cutter stuff, just to show them that you can get Python to talk directly to the server and provide answers to users through the form of, say, a kiosk application. So this is the overall design, and you get to a sense where you start to ask the question, do you get what you pay for with open source software, right? So it's free, so maybe it's not that good. So what I want to do now is dive into all the things that my students did with these different technology stacks within the open source environment. So this is an example of what that web page looked like. And here, the students made a quick little video just showing how they could build a web page, bring in imagery from the state, toggle on and off different layers, and then also filter things. So they could look for residential properties that were built after a certain date. You see those light up. So here we have a client on a web browser interacting with a server that's performing GIS activity. So here they're looking at agricultural data since 1900s, and some of those boxes that pop up they were just doing for testing. So I wanted to show a little bit of that. So that's how we see how these things work together. Here again, you can bring up the different trees that are in the town, and they can look at all the trees that are within a certain distance of commercial properties, and those show up, and there's zooming in and zooming out capabilities. So they're using open layers on the front end with their web browser, and they're hitting on Geoserver on the server, which is also talking to Postgres, which is delivering up the data. So this is a full three-tiered type system that we're working with. And again, they built this in a very short amount of time. So again, what were we seeing? Well, the first thing was there was a browser. We saw that browser, and it was asking questions like, find me the commercial properties that are after a certain date. Well, that browser is talking to our server through Geoserver, which is an open source internet map server. Geoserver, in turn, was actually talking to Postgres, which is an enterprise class database, getting the results from that and then turning those results back to the user. So this is a relatively sophisticated thing that they put together in a very short period of time. And most of the layers were created with QGIS, which we then loaded into Postgres. So let's dive into the first part of our stack, which is the desktop and QGIS. So QGIS is a desktop GIS package. It has a very user-friendly interface that you can learn from, and with it you can visualize, manage, edit, and analyze data, and especially spatial data. What's really interesting about QGIS, of course, though, is being it's open source, it's running on Linux, Unix, Mac, Windows, and Android operating systems. This is very interesting for me during the lockdowns and the quarantines for the COVID-19. Our students had to go home, so we put them on things like QGIS. Some of them had Macs. They didn't have PCs, and most commercial GIS requires a Windows-based computer. So they were actually able to run QGIS no matter what operating system they had. So why are we looking at QGIS as an open source solution? Well, one is it is a full functioning desktop GIS. It's probably the most mature open source GIS that's out there. There's also, we're going to show you this a little later, plugins that expand the capabilities of the software for no cost. There's huge and vast numbers of people out there in the community that are building plugins that answer different kinds of spatial questions. Also, QGIS can connect to various types of data, including enterprise class databases like Postgres and SQL Server and Oracle. There's also something called the processing modeler, and that allows us to create complex queries very similar to what you've seen in maybe ESRI's model builder. We'll demonstrate a little bit of that as well. And then we can also write our own SQL queries to enhance the capabilities. And that gets into the developer end of things, where you start to develop your own code to create solutions for the problems that you have. So let's look at plugins. So QGIS was designed to allow third-party plugins to occur. And you can see over here, I've got a whole bunch of plugins. This is the plugin window, and we're just scrolling through it. It's a GIF, so it's going over and over again. But there are hundreds of these that are third-party plugins that are tools which expand the capabilities of the software. Some of the plugins come built in with QGIS, and others you can bring in from the outside. So here's an example of what a plugin might look like. If you're using MySQL, you can actually bring in the plugin for MySQL, and it will show you the name, and it goes right into the QGIS community. So you can see all the different plugins that are here, just beginning with the letter M. There tells you the number of downloads, the rating. So is this a good plugin? Do people like it? It gives an overview and a description. So then you can go in and you can click to install the plugin. Can look at another one. This is one that we really like using, which is using QuickMapServices. So if I want to bring in a backdrop or a base map into my QGIS interface, and you saw that earlier when we had the background map, both the imagery as well as a map, we can bring in data from ESRI, we can bring in Google Maps, there's Bing Maps as well. So there's a whole bunch, and you can see we barely even started scrolling here. So there's many different plugins you can bring in for bringing in base map. So let me show you the demonstration of how one of these plugins works. So here I'm going to look at visibility analysis. You can see, of course, the background map, and I clicked on visibility analysis, and I added that as a plugin. I've got a bunch of points, and I then click those points, and I then ask where can I see areas from those different locations. So creating a view shed, and that's something again that we can do right with a plugin. So QGIS doesn't come with viewshed analysis, but someone's written a plugin that easily adapts in, and you can see you just click relatively easily on this, and you can bring in your DEM and then have the viewshed show up. So that's not the kind of thing you would think with free software, right? You get what you pay for. That's pretty sophisticated stuff, and this is just one example of hundreds of plugins that are available within QGIS. QGIS also works really well for data integration. Here you can see we're looking at some vector data, raster, text, geopackage, spatialite, Postgres, SQL Server, all different WMS, WFS, ArcGIS map servers. We can bring all of those in. You can also see here that you can connect through the database manager directly with something like Postgres or SQL Server. And if your eyes are good enough, you can see Oracle, so you can connect directly with that. So major relational databases. So this is really easy to begin to click on this window and start to bring in data. Now the question is, does it give us a lot of options? Well, sure. This is looking at the vector data. So I'm just scrolling through and look at all the different formats that you can bring in. So it's not just shapefiles where a lot of packages will do that. This can bring up pretty much anything because it's using what's called the Geographic Data Abstraction Library, which is what most of the commercial vendors use to bring in data. So there's a ton of vector-based data that you can bring in. There's also raster-based data. So again, look at all the different raster layers that you can bring, all the different file formats. And again, remember, this is free. I'm going to keep saying this phrase over and over again. You get what you pay for. Well, in this case, you get a lot more than what you paid for. So lots of the popular ones like ERDAS, Adrizi, USGS DEMs, but many, many more. You can see them all in there as we just kind of scroll through the list. There's also another tool called the Processing Modeler that works a lot like Model Builder in the ESRI ArcGIS platform. So this is an example of we can put together a chain of operations into a single diagram and then run that model. And it's really nice, and you guys are probably already familiar with the concept of Model Builder, so it's really nice to make a model. It's easy to understand. It saves time, especially for tasks that are having to be run numerous times and you want to just change one or two variables. So here's an example. We asked the students from an old GIS lab they had performed in a previous class to locate the ideal spot for a kayak rental company. So it has things like it's got to be 4 miles from any municipality, can't be on a main road, the roads have to intersect the water, must have as much forest cover within 500 feet of that intersection. So you can start to see already we're getting the students into selecting by attributes, selecting by location, buffering, intersecting, clipping, all those sorts of tools. So it is what it is in terms of a lab, but it's giving the students the base elemental functionality that they need to become proficient in GIS. And what you see here is the graphic model that they created. So here you've got, you can see they're using a dissolve command where they're dissolving certain boundaries away. So you've got, we're merging different files together. There's some buffering that you see here. It's using the erase function for certain things. So a lot of different types of selections and intersections, and here's clipping. So many different types of functionality that get us down to our final result. And they found their top 3 areas, what I asked them to do. And they did the same thing, of course, in the GUI. So using all the base tools in something like QGIS that has that same functionality, but now they could call that functionality from inside the model. Now, as you get a little more advanced, you can use the model builder, which again, my students love. So they've got some merged data. So they're merging municipal boundaries, and then they're buffering it by 4 miles. So they get this 4-mile buffer. That's nice to do, and you can see kind of what it looks like here. If you start to move into the developer stage, open source software has that capability as well. This is some SQL code that does that. Let me talk you through it. Don't worry about being an expert at this right now. But what we're doing is we're unioning, or in other words, joining together Wicomico County and Worcester County. And we're going to call that Wico-Wark, or Wark-or-Wus, right, for Wicomico and Worcester. There's a third county we had to bring in, which is Somerset County. So we've wrapped this in parentheses, and now what we're doing is we're unioning the Wico-Wark, which we just created here, with the Somerset geometries. So now we've merged all 3 of those together. We union them, and then we buffer those by, again, in this case, the 4-mile buffer, and we do that in meters. So a very terse amount of SQL code, you can see, performs quite a number of steps that you do in the desktop and a few different steps you might have in your processing modeler. So QGIS provides all those base GIS functionality along with extended tools, along with the ability to connect to multiple data sources all over the world, online and both locally, and all different kinds of data formats. And all in all, I'd say my students were very impressed with the capabilities that a free software product like QGIS can perform. We then moved more to the server base. So looking at an enterprise class database. So that's using Postgres. Now Postgres has an extension called PostGIS that brings the spatial part into things. Now Oracle has that. They have Oracle Spatial. SQL Server has that. They have SQL Server Spatial, and a number of other products have it as well. But when we think about enterprise class databases, we're thinking about the things that run hospitals, that run airline reservation systems, that run banks, really big utility type databases. And what we do is we just throw GIS data in there as well, and we begin to model that. So you can see, I'll bring this diagram back from before. Here's Postgres. That is on the server. And because it's a real enterprise database, not something like Microsoft Access, this thing can reside on a server somewhere with an IP address, and people can get to it from the internet or through just Ethernet cabling from the local office as well. So it truly is a multi-distributed database. This is the kind of stuff we don't ordinarily get to in a GIS class. It almost seems like building an enterprise class relational database system is a bit too advanced. Well, truth be told, my students were able to do this in a relatively short period of time. And let me show you some of the advantages of having the data in a server and maybe performing something like SQL. So here's an example in QGIS where we're using the graphical user interface to select data based upon different criteria. And here we selected all the parcels that are in the Lansing School District. And now that that's done, we can go in and open up the attribute table. If again, you're watching over here, and we're going to be selecting by an expression. So we select all the properties that are residential in those areas. And now we have an example of all the residential parcels in Lansing. Let's look at this again in Postgres with SQL. Here, I'm just opening up the database and I'm issuing some SQL. You can see the SQL right here. That's it. That's done. You can see this is finished a long time ago over here, and we're still operating here with the GUI. So what we just wanted to show in this little animation is one very simple SQL query does everything we just asked to do in multiple steps using the GUI. And we can do this when the data is in Postgres, so we can issue the SQL that PostGIS allows it to perform. And the way we do that is we just connect to a PostGIS instance. Very easy. Another tool in QGIS is to create a PostGIS connection. So we can connect to our particular host with a username and password, and then we can take any data layer that we have. It could have been a shapefile, a geo package, an ArcInfo coverage. As long as it's in QGIS, we can say, why don't you export that to Postgres? And it will take that data and move it into Postgres for further use. And again, another free product. If you only use QGIS just to take data that's out there and moved it into SQL Server or Oracle or Postgres, that in and of itself is worth the free price tag. So that's really powerful. And in fact, even for the commercial work that I do, I often use QGIS just to get data into my spatial databases because it's just so easy using these tools that they've put together. Another thing that's really important to think about when you're dealing with a relational database and the data is stored in it is it operates like a true database. I use the example of a hospital or a bank. The reality is not everybody can see your medical records. Your doctor can, maybe the billing manager can't, but the billing manager can see certain things that the doctor can't. Maybe the doctor doesn't want to know about how things are priced because he wants to focus just on your health. Well, what they do in hospitals is they create different roles. Doctors, technicians, right, who read the x-rays, billing people, nurses. Well, we can do the same thing. And my students did that. They created the role of an analyst and they created a role of a technician. And they granted certain privileges to the analyst and certain privileges to the technician. So there were certain things that the technicians could not do. So the analyst could do anything. They granted all the privileges. The technician, he could only select, insert, and update. So that's some of the things that they can do. Notice there's no delete here. A technician, as much as he wants to delete an object in a database, he can't because now we're treating the geographic object as a true database element. So we have lots of control using things like roles. And again, Postgres with PostGIS is free. We're building the foundation of an enterprise class spatial data server with this free software. Another thing we can do, and again, my students just learned how to write this. It's a really short amount of SQL, but they are executing certain access to only some tables. So in this case, where the name is like parcels. So this case, we can give a technician or an analyst a certain amount of access to only particular tables. And then we can create different users. So here they're creating a user named Bob, and he's got certain things he can do, certain things he can't do. And now we've allowed Bob to be an analyst. Now Mike and John were two other users we just created, but they're technicians. So now I have Mike and John and Bob and finance and analysts, so all different kinds of groups and users that are part of those groups. So again, think about your bank, your branch manager, your teller. Some people can't see and have access to data, or they can view your account. They just can't deduct money from your account. That's only certain privileges. We can do the same thing with GIS data when it's stored in a relational database like this. And Postgres with PostGIS makes it really easy to do that. Another thing that's important is what we'd consider multi-user editing. Here you can see down at the bottom, I'm digitizing a polygon. I've got two sessions open. There, that polygon is completed. I save it, and I come up to this top box, and I move the map, and look, there's that same parcel. Now here I'm going to digitize another parcel. So this is a different user. I'll save that, and we'll come down to the bottom one, and we'll pan. And there it is. You can see it showed up at the top, and this is going to run over again. This is important. Think about an airline reservation system. When you're making a reservation to get a seat on a plane, it's not like no one else can reserve a seat, right? Lots of people are reserving seats on those planes at the same time. That is called multi-user editing. We see it in hospitals too, when people are updating records. We see it in banks. People are depositing money. In a lot of GIS, the minute someone grabs a layer, like the parcels, or in this case, these are the buildings, then we freeze the whole layer and nobody can do anything. You got to wait till your friend is done editing before you can edit. Well, here it doesn't matter. It's a multi-user system. These two users are simultaneously adding buildings, and each user sees what's done as a reflection of the other person's work. And again, this moves us more to an advanced use of GIS, seeing it as an enterprise type server versus just a single standalone thing that you would use on your PC. Well, another thing we can do is create something called constraints. So for example, when I'm going to put a land use value in a new parcel that I create or change one, I'm creating what's called a check constraint. We build this in the database and we say, if you put it in, it better be called agriculture or apartments or commercial. If you spell agriculture wrong, it will not allow you to put it in there. Or if you put in something else that's not in this list. So the students wrote these check constraints on the back end. So that way when they start to edit data, like I showed in this previous slide here, and they spell agriculture wrong and just call it ag, then they're going to get an error. We could not commit the changes. Why? Because it violates the constraint that was created. You've probably all heard, right, about the importance of good, clean data if you want to do good analysis, the whole garbage in, garbage out scenario. This is the best way to make sure we keep garbage out and we just put good data in, is we create constraints that require the data to fall under certain scenarios. So this is an example of spelling for different types of land cover types, but we could do the same thing for water mains, and they should have only certain diameters that we would use. And if you put in a different diameter that's not there, then it's not going to work. So you're going to be able to constrain the user, that's why the term constraint, to particular attributes that you want in your table. Here's another interesting thing, and this gets really, really advanced. This is called triggers. So a trigger, you think about a trigger on a gun. You push a trigger and the gun fires. There's a trigger in a database. Do something to the database and something fires. Well, I'm going to show you a little bit of this code in a moment. And again, my students had never done this before, but they wrote their own triggers. Here's what they did, though. We'll look over here. They tried to digitize a building outside of the parcel fabric. And what happened was they got an error. They could not commit those changes because that one of the triggers, one of the rules was if you digitize a building, it needs to be inside a parcel or needs to intersect with a parcel. You digitize one out here and try to save it, the database can say, no, that's not going to work. You can do the same kind of things with forest boundaries or soil boundaries. Maybe you can't have holes and gaps in a soil fabric, or street center lines can't intersect a building or something like that, or a sewer pipe. A pipe has to be connected to a manhole. That could be a rule, and we build a trigger. So what we did was they created a trigger called update structure, and this is before we insert it into the database. What has to happen? Well, they want to check that the new geometry that we created, like this one here, is within the centroid of that new geometry. So I'll put a little centroid here. They want to make sure that's within the parcels. And if it's not, then it throws an error and says the structure must be in a parcel. And that's it. Now you might think, wow, I wouldn't even know where to begin writing this. Well, neither did my students or I, but there's lots of examples where people may have shown how to insert a new record album into a library for a record store. You've probably seen examples like that all over the internet, just showing how to create a trigger. Well, okay, it's not a record album any longer. It's now a parcel polygon, and it's a building. So all those things can be interchangeable because, again, we're treating this as a true database element. So once again, let's review. We now have an enterprise class database that has certain rules for these different users that restrict what they can and can't do. And the really cool thing is they can use any of these products to start to edit data and query data and do things because the data is just being served by the enterprise GIS. And again, each of the users are told what they can do, what they can't do, and when they do a particular action, we can also fire off a trigger to have something else happen in response to that, like preventing a parcel from or a building from being entered if it's not in a parcel. Another thing we can do is we could update the value of a parcel if we digitize a building inside of it and maybe update it with the amount of square footage of building that's inside the parcel. It can sum all of those up. So the user doesn't have to do that. The database itself does it because it has that intelligence in it. So now we'll look at our last part of the stack, and that's Geoserver. So Geoserver is a internet map server that is built on GeoTools, which is a Java-based toolkit, and it implements industry standard web mapping services. These are those images that come across the web feature services as well. So that will allow us to stream actual vector layers. We can integrate it with things like open layers and leaflet and other types of tools. So again, that sits on our server. And the great thing again is the GIS can look at the data from the GeoServer without any trouble at all. Also, the Postgres can start to interact with it as well. And then more importantly, people from the internet can start, and web browsers can begin to interact with the data. The really cool thing is with GeoServer talking to Postgres, that means your internet users can actually see your Postgres data if you allow them. And remember, we have all those from those roles and constraints that we created before and triggers. We have ways to protect our data as well. And Geoserver is a really robust tool for internet mapping. And again, it goes back to you get what you pay for. It's free, but it does a lot. So you get way more than you pay for. So it can work with different data sources. It can work with vector files. It can work with databases. Again, all the major databases. It can work with different servers. So you can even read data from ESRI enterprise servers and web feature servers. We can work with all kinds of raster data, other kinds of vector data as well. You see here, Google services. We can have different kinds of stylized maps through the web map service that you can create. So you bring out a map, like maybe a land use map, and it's covered or it's colored by the land use values. Also, there's raster data as well, GeoTIFFs and ESRI grids and JPEG 2000 and ERDAS IMG files. All that filters through Geoserver and then lets the world see that realization. Because think about it, in Postgres or in anything, we've got a parcel map out there, and it's just, it's just one color, it's gray, but it's got attributes in it, right? So we can color code things by the land value. Well, Geoserver can do that and then present that look to the user. And you saw that in that very first slide or that very first video that we showed. The trees were colored green. We can actually stylize things like that. The properties were colored by their different land use types. Here's just an example of where my students brought in shapefiles into Geoserver. They also brought in a new vector data source in an enterprise GIS using Postgres, right, with a username and password. So and here we had we used the Three Stooges, Mo, Larry, Curly, and Shemp. For Geoserver, we only allowed access through Shemp. So that when we were presenting data, people couldn't edit things. They couldn't even see any real information because we wanted to protect that. We could have given it one of the other usernames so that they could have had more access. But this was just an example to control what the outside world can see. Now, Geoserver is fairly bare bones when it comes in, so you have to bring in different modules to get things to work, and the students have to do that. So there are core modules that allow the system to function, but then there are extensions, just like those add-ins that we saw or the plugins that we saw with QGIS. Same kind of thing. So there's one for SQL Server. So SQL Server wasn't natively read with Geoserver, so they built a plugin that allows you to bring that in. There's another one, a query layer, which allows us to issue queries across different layers. So I can find all the parcels that intersect the forest that are, say, residential. That's performing queries on multiple layers, right? You got the parcels, and then you have the forest boundary. That's a little more sophisticated than you would think. So there's a plugin that allows us to do that. So my students did that, and they built it, and they created that application that you saw earlier that can perform those multi-layer queries. Here's an example of Geoserver. We can look at it and you can see the map is colored in and we're just adding styles to it. So we added a style which was the land cover type and we saved that. So and it creates this all the XML data for it and we can put it in there and we can publish that data using that zoning class. You can see that just got generated. And when that gets completed, we can put that into the HTML and then up comes the map and you have the nice color. What's nice about that is you could see this animation is actually doing that entire thing. And what is really nice about that is we're not writing any code. That code is generated for us. So that's a really nice benefit. Normally you'd see it was gray and now it's got all the colors. And then they saved it again, put it into the HTML where we call it, and then you can see what the map looks like. That's a really pretty looking map that's served over the internet. And again, it's just done by clicking things and being stored on the server and presented to the user. The other cool thing that Geoserver does is allows us to create filters. These are called CQL filters, not SQL. So it sounds like SQL, right? CQL. What they're doing here is you can test out different filters. So I want to find geometries that are within another kind of a geometry. So we'll wait for this animation to cycle through again and you'll get to see a little more of what that does. So here we have our map and we're testing it out. So I want to find all the buildings that are within commercial type, excuse me, all the parcels that are near buildings, and here we are putting it into our HTML. So we're just showing you that based upon the building classification. So again, I want to find all the trees in a certain distance. So here it's the trees within 50 feet of commercial buildings. When we click on that button, you can see that the map then refreshes and shows me only those buildings that are within the 50 feet of the commercial buildings. And here you can see the 50 feet that was just sent there. So here we tested it out. That's what it looks like. Then once that worked, we took that same query that was written in that CQL wizard or dialog box, copied it into the HTML. You can see that happening here. And then we can go into the actual web page and put the 50, put the commercial, hit the filter trees, and out comes our result. Now that's a little slower because it's working on the data inside of Geoserver, but the other thing we can do is create SQL views. This is actually where Geoserver is talking to Postgres. So we're going to create a new layer and we're going to configure an SQL view. So this is that SQL query we talked about, but now we call it something called prop class and year. They're in parentheses because they're just variables. So we might want to know properties that are residential that were built after 1900. So we just created that, and this is the query. And we can then test that out. And then once we've done that, we can take those same view parameters and we can put that into the HTML document. By the way, this took them a little while to do, but relatively easy. And here again, they hit filter parcels and look at the yellow parcels that came up from 1900. And then we did 1950. And you can see more parcels show up. And then we can change it to townhouses from 1950. And notice this is all happening over the internet. So the user is issuing SQL queries over the internet. So what you see now is the user asks a question of Geoserver. Geoserver goes in, passes that question to Postgres to use all that really nice, powerful spatial SQL, gets the answer, sends that answer to Geoserver, and then Geoserver makes the little map and sends it off to the user to see what it looks like. First, pretty slick stuff for free, but also pretty slick stuff for just learning it. And in this case, the students have to do the Geoserver part of the class in about 2 weeks. And some of the things that they learned through this whole process is that FOSS4g and commercial software both have strengths and weaknesses. And there were certainly times people were getting frustrated with the software. It didn't do exactly what they wanted. But we also found that they're really effective when they're implemented together. A long time ago, there was this argument, is this one better than that one? And that's fine for, sitting around a bar and discussing things with your friends. But really, if you want to be a productive geospatial analyst, let's learn to get all of these good products talking together. Um, Also, the dynamic nature of FOSS4g allows users to learn as they implement the system. Um, so this has been really great too. My students can just kind of do this at night at home because they can download all the software. It was really easy. There's really strong online support community. And then the other thing that's not really a requirement, but boy, if you want to grow in your GIS career, learn SQL. So some of the things that my students learned, again, at least about the strengths and weaknesses with FOSS4g, it's free. There's really dynamic. There's great plugins, online community support. The challenge is there's not a lot of training. The other challenge is, maybe you have to do a little more programming to start to learn some of this. Although I think they found they were able to replicate their regular GIS labs using QGIS relatively easily. Commercial, of course, the advantage is the familiarity. Also, there's pre-existing systems that are already in place that people are using, so you don't have to learn something new. And there's much more, a very good dedicated customer service. Now, again, I can't say enough about how good the online support community is for FOSS4g. But at the same time, the dedicated support service you get when you pick up a phone and call your commercial vendor, that's something that you have to really consider. Some of the challenges, again, with commercial is there's cost and then just how things get updated and how they're structured, how the cost sharing might change in some of those things. But all in all, again, they should be working together. This is how I started the class off, by the way. There was a talk by Michael Turner on the role of geospatial open source as a component of hybrid systems. This is in 2014. And he basically posed a question, what are you trying to do? You're trying to pick the best tool for the job. I would suggest you look this talk up, FOSS4g 2014. Take a look at that. Mike does a great job. Hopefully this presentation can kind of augment that to see how these things work together. So the FOSS4g stack works best when it's filling in technological gaps of a system you're currently using. Another thing the students said, again, is the dynamic nature allows them to learn as they implement the system until they learn how to really fully integrate the workflow. And also it can be substituted in and out of workflows that you currently have. Now, it is possible to use for desktop GIS, ArcGIS Map, and QGIS. And there's trade-offs in all those things. ArcGIS has a rich set of tools and integration because ESRI is a really great company that's done some really great things with the product, but many of the tasks that you perform, you can do in QGIS. Same with ArcGIS Server and Manifold. You can do different things with pgadmin 4 or pgadmin, which is basically the console to talk to Postgres. So Postgres with PostGIS does a lot of the server-based GIS. I showed you a couple little examples of the SQL that we were doing. Really powerful stuff. But you're going to need to learn how to do some of that on your own. But that becomes a very powerful tool as well. And again, consider the trade-offs, right? Something like ESRI's ArcGIS Server or ArcGIS Enterprise or Arc Online, all of those things have thousands of man years of development behind it, and it's backed by a commercial-based company. So there's certainly advantages to that. But lots of those things can be replicated with the open source tools. And then for just developer, you can use Geoserver with some of the tools. And again, I think what my students found was the ESRI tools, oftentimes for the developer end, was a lot easier. I've got a course in ArcPy that the students take. We also do some Python with QGIS. My students right now find ArcPy way more easy to use. It's a much better object model. So in that case, that's one where I think the open source community has to work a little more to become a little more user friendly in the way that ESRI has made ArcPy very user friendly. And yeah, it's free, but there's a very strong, tight-knit, and supportive community. Here's just an example that you see here in a community wiki where someone's asking, are the slides available for the FOSS4g presentation? And then they have all the examples here of where to get things. You'll find too on things like Stack Exchange and Reddit, people will ask, how do I do this thing in QGIS or Postgres? And people will just write and give them the code to do that. So we solved a lot of our problems by going to those sites and getting code snippets and using it. And of course, learning SQL can only increase your success with FOSS4g. There's a lot of people who've talked about this. Do not ignore the power that SQL and database management brings to your toolbox. It is worth spending time learning those kinds of tools. It assists you in speeding through and bypassing many of the tools because you can write queries like we have here. In fact, this is a good one to just talk about. It's very English-like. I want to get the minimum distance between the parcels and the flood zones, where the parcel is this certain parcel key and the flood zone is AE. In other words, I'm asking, what is the closest flood zone, the AE flood zone, to this particular parcel, and how far is it apart? Or this one up top. Here I want to get all the parcels that are inside the Fall Creek watershed. So I'm selecting the watershed equal to Fall Creek, and then I'm doing a containment clause to find the watersheds that are inside the parcels. So just to review those 5 takeaways that my students had by going through and using these tools, they found that they both had strengths and weaknesses in commercial and FOSS4g software, but the FOSS4g software was able to complete all the labs that they performed in their GIS task. They did see that they were great when they began to work together so that we create a hybrid and integrated system. And also, again, we were able to figure out how to work the FOSS4g software into our workflows, and we made extensive use of the online support community. We could not have gotten through this class without the help of all the people who contributed online to answering questions. And finally, this is something new to my students, this idea of SQL and spatial SQL. They all walked away saying, I need to learn more about this. And I think as you start to explore the use of spatial SQL, you're going to see a real reason to do that. So again, I just applaud my students for doing a great job, really getting through the whole COVID-19 shutdown and all that, and learning some really significant things. I hope that this has been helpful for you to think about, is open source software something that's a viable thing for me? And also maybe get you to away from the whole idea of is it an either or. It's really a both, the best of both worlds. How do we integrate some of the open source software that we have with our commercial software? Other thing, I would just like to thank Susan Brazer, who's one of our librarians at Salisbury University. Susan is a great resource for the students, especially when helping them think through how to put together a presentation that communicates well. And finally, if you want to learn more about open source software, you can go to artlembo.com. This is where I have a bunch of online courses. I've got one in QGIS Desktop. I've got one where we build an enterprise GIS with Postgres and PostGIS. If you want to dive in and learn spatial SQL with Postgres, I've got a course in that. I've also got a course in how to build an internet map server. By the way, all of my students went through these videos in order to learn how to use the software to conduct these tests, to perform these activities, build these systems, and then present this all to you. And I've also got one on Python for geospatial. If you want to dive into learning how to write Python code, not just for open source, but also for things like using ArcPy. And of course, I've got a book and a video series on statistical problem solving in geography. This is really the foundations of what quantitative geography is. So it's a great class you can get through to learn how to do quantitative analysis in a academic way and in a scientifically valid way. And finally, all these students were part of a course that I taught in Open Source GIS in our graduate program in Master of Science in Geographic Information Systems Management. This is a management degree for GIS. It's not a technical degree, but you'll notice just from this presentation, we do have a number of technical courses in our management program, primarily because you're not going to be a good manager if you don't understand the technology. So you will get your hands on GIS technology and doing things like open source and enterprise-based GIS within this course, but you'll also learn a lot more about the management aspect of GIS. So I encourage you to go and visit that. Just Google the Salisbury University Management in GIS, and you can check out our degree program. It's fully online, and people are able to get through that in either 1 year or a 2-year option. So anyway, I hope you enjoyed this talk. I hope you have an opportunity to explore open source software for yourself. And if you do, leave a comment. Let me know what you think.